And welcome, and in this video I'll be talking about career options in robotics. My name is Anirban Ghatak and I'm the founder of MyRobot. Now a lot of people, especially those completing high school or even undergraduate, have a lot of question mark in their mind. Say, what do I do to have a successful career in robotics, and what happens when you are enrolling yourself for a robotics journey. So there are a lot of question marks, as you can see, and I'll try to decode them in simple language so that it is helpful for you. All right. Now, before we start into robotics, just to give you some context, because I'll be talking about a few examples, and it's important that I get everybody on the same page on this kind of robot. I have left out this kind because these are the hobby grade robots, the robots which you do generally with Raspberry Pi, yeah, and you also do with Arduino. Okay, so those are mainly for STEM, which is science, technology, engineering, and management kind of th thing. It is also very good for hobby grade, yeah. But bear in mind, none of these two things, which are Raspberry Pi being a single board computer and Arduino being a microcontroller, there are, non-production. So what do I mean when I say non-production? Non-production means that you cannot use it in industry use. Correct? So if you are using a robot which is used in a factory, or if you are using a part of a robotic system used in a say drone, the probability that you would be using a hobby grade thing like an Arduino and Raspberry Pi is almost close to zero. Okay. The other thing is that, since this is for STEM, there is also no demand for this skills when it comes to jobs. All right. So if you go and search in a job portal, you will not get a job which says that, company XYZ needs an Arduino developer. Correct? All right. So, but just to correct myself, I'm not saying that, and just to set up the right context, I'm not saying that this is bad, but you should be having realistic expectation when it comes to STEM, because these are only for hobby. It is also a wonderful thing to people get people involved into science in general. So, this came in when, you are getting people involved in science. So it's wonderful when you are doing such kind of things for a STEM kind of a thing. All right. Now that I have already talked that, what are the robots which would be used in the industry, because I've already talked about the robots which are used in STEM education. So these are the robots which I would like to talk. And the first type of robots are the mobile type of robots. And what I mean by mobile, these are generally rovers, and they are wheel-based robots. So generally, there is a base and there are four wheels, and there might be sensors and cameras which are mounted, and they would be connected to some other centralized platform, and they would be sending data, receiving data, and doing some action or work. Correct? So this is one type of robot. Uh, this type of robot is, 90% of the production robot over the world globally belongs to this category. And these are nothing but, your robotic arms which go and do the work. For example, in in automotive company, such robots actually, go and create the body of the robot in things like body shop. Okay, so robotics arms, they're used for weldings, they're used for bending metals, they're exclusively used in the automotive industry primarily. Okay, and this is very employable skill. So, you have work where you have installation work of the robot where you go to a factory and install these robots. So there are also service engineers role where you go and do the maintenance of this robot. The next criteria are aerial robot. The normal term is drone, and it generally refers to defense kind of an aerial robot. But you also have multi-rotors, and we also call it as quadcopters, which is a very common, again, a hobby interpretation of an aerial robots. And bear in mind, they should not fly. They should be also doing some work, like monitoring or delivery of payloads. Correct. Then the next type of robots we have are software robots. And here, there are generally two types. One is the RPA, which is nothing but robotic um, process automation. Okay, and then you have the software boards which are there with some kind of artificial intelligence like AI enabled recommender engines used in e-commerce. Okay, used in e-commerce. Now this is also very employable. Okay, this is also very employable. When I say employable, I mean that there are jobs in the market for this particular robots. All right, and then you will also have some robots which do certain kind of automation, like pick and place. Is a very good example in which a robot will pick up a thing from location A. So if this is your thing, it will pick up from location A and place it in the factory, the same thing in another location B. One example could be a bottling factory or a simple jam and jelly factory. Correct. So these are the various type of robots which you have, and that probably gives you certain kind of baseline knowledge as we move forward. Okay. Now, what are the core areas of robotics that so far we have seen the types of robots. What would be the core areas of robotics? Now, this, if you look at it, these are the core areas of robotics. Yeah, in a nutshell. Okay. So the first thing is kinematics and motion, okay, and it generally has things like inverse kinematics, forward kinematics. This has to do with movements, the physical movements, I mean, and joints, uh, angle, and position, etc. Robotic arm is a good example of kinematics, and so are the motion, in which you do the trajectory, or you also do the path planning. These are all example of kinematics and motion. So if you're going for robotics education, kinematics and motion would be a subject within robotics. The next is machine vision. The most common use of a machine vision is a subset which is called as computer vision. And generally, these are implemented with software as MATLAB or also with, OpenCV. Okay, and in turn, OpenCV version 3 is the latest. They use C++ and Python. Okay, under that, you can interface them with IMU, which are your, something with to do with your inertia, maybe a gyroscope, and obviously you can have a leader, which is a laser guided device, and you can also have simple cameras. or even a webcam. Okay, so you have to, if you are doing a robot has to identify humans or identify a table, and how do you do it? One of the ways that you do with computer-based algorithms called as computer vision. All right. Obviously, in hobby electronics, we use an ultrasonic sensor, and if there is a obstacle, it detects, and then it takes a reverse turn. But again, those kind of logic you cannot use for a production environment. And even if you use an ultrasonic sensor, you have to back it up with other sensor or other means for the robots to achieve what it aims at doing. Okay, the next thing is localization, and in this we have a concept as a SLAM, and I will be putting a link to my SLAM blog, and you can see that how I have implemented a SLAM for a simple robot. And this actually means that when a robot is moving on a particular space, and this is the space, this is where the area is in the total area, and here you might have your robot. It should be able to draw a map as it moves, because at times your GPS based navigation might not be there. So the robot should be able to check surroundings and do a self guidance. So localization and SLAM is a fundamental problem statement in robotics. Here you would be, again, if you study it, you would be getting exposed to things as Kalman filter, also control systems, concepts of PID, yeah, Monte Carlo simulation, etc. So this is a very important and important aspects when you are studying robotics. Okay, so the next area is artificial intelligence. I'll just go and clear the screen. Okay, so the next area is artificial intelligence, and here, when it comes to robotics, I know that this is a very hot area when it comes to career, job, employment these days. But when we look, I know we as robotics engineer, the area which is very important for us are generally neural networks, especially to do with images and videos. And we also have an important area which is under the area of reinforcement learning. Yeah, so reinforcement learning is the main area within artificial intelligence, which is very important for a robotics engineer apart from neural network. The next thing is cloud computing, and I think everything is going into cloud, and especially how to handle storage of data within the cloud. That is of interest to us, and also how to interface robotics with IoT standards. That is also very important for robotics engineering. And cloud options are AWS, which is the Amazon cloud, then you have the Microsoft cloud, which is the Azure, and you also have the GCP. And depending on your research requirement or your customer requirement, you would be going and scaling yourself into cloud computing as such, especially in the area of storage, data, IoT, and probably I'll also add networking. Yeah. That brings us to the last area, and this is interesting because you need a platform to control a robot. Let me tell you what I mean. Suppose you are making a robot with a simple stem-based microcontroller like PIC or Arduino. Okay. Now the number of GPIOs are limited. It's less than 20. The best you can take is probably an Arduino Mega, comment up if I'm not right. So the best you can take is an Arduino Mega, and I think it has less than 20 or 24 I/O pins, which means that that's the maximum number of sensor you can use. Now imagine you are designing a humanoid robot, okay, and you need obviously a lot of sensor for this particular robot, and you cannot just do it 24 sensors, right? And so what do you do in such a case? Because you cannot have a single program running in an infinite loop in such a case of a humanoid, because it's just not possible. Your program would be very big and calling multiple cases. Now, what if this humanoid has to interact with another mobile robot, which is sending data to the robot? And what happens if there is also another drone flying over the sky, and this drone is talking to this aerial robot? And finally, you need a central monitoring cockpit, okay, a computer maybe, in which you here needs to control all these three robots. And in such a case, you cannot use a single microcontroller based platform. You need a platform of a Meta OS which controls all of this using a publisher publisher subscriber mode. Yeah, and one way to do it is using a Meta operating system, as we call it ROS. ROS stands for Robot Operating System. Okay, so this is what I mean by platform and Meta OS. Meta base, because ROS sits on your on base operating system of your laptop or your server. Example, your server is running Windows 10. We installed Ubuntu over it, and over Ubuntu we installed ROS as a Meta operating system, which goes and connects everything, and your computer, the controller, becomes the master or the ROS core, and all of this become all these three robots probably are nodes. Nodes 1, node 2, and node 3. This is an oversimplified explanation of Meta operating system within robotics, but I think that gives you the concept that why do you need a platform and a Meta OS, and why a single microcontroller based solution is actually not useful for an industry based solution, correct? Because the use cases are totally different than the robotics project when you do for hobby. All right. Now, what are the key subjects that we need to do? And this again is a highly capsule list of subjects. I think if any professor is looking into this video, I'm sure that he or she would say that this is oversimplified, and I agree. You need much more than this. But these are the bare minimum without which doing robotics engineering it's not possible actually. You need a very strong grip on physics, because especially vector, no brainer for it, because this is actually the base or the mother subject. Okay, and this is also the science. Okay, and what you're trying to do is you're trying to go into the field of engineering with the help of the base subject, which is physics. Then you need maths, especially linear algebra, geometry, calculus. Depending on what area of robotics you are using, you would be requiring it. Example, if you're doing kinematics, you would need linear algebra. If you're doing OpenCV, you would need geometry and calculus, and at times you would need a combination of all the three. Set theory and probability is very important, and probabilistic robotics is coming into picture. So both set theory and probability is also very important when it comes to robotics, because take one example of localization. So the robot in localization, as I said, that you have an area, and the robot is in a zone, and this is the robot. Now from going from point A to point V, the robot makes a plan like this and gives you a map, and this is how we have gone from A to B. But in actual, your map can be a little bit different. Okay, so in such a case, if, the robot uses probability, saying that what is the highest probability that I'll go for, successfully from point A to point B. So there is a lot of probability which is used when it comes to mapping, especially in algorithms such as SLAM, which I talked earlier. Yeah. So the other thing which you need to know is computer engineering, because a lot of aspects of computer engineering is involved, and robotics is a hybrid engineering branch combining multiple branches, and you would need especially networks, computer networks, reinforcement learning I've already talked, and obviously a strong grip on operating system, because you would be playing with a lot of things, and especially Unix. If you're looking for research grade or industry grade robots, Unix is not negotiable. You also need Unix command line thing, which again maps into the thing. Programming language, I think C++ is the main one, followed by Java, and especially the Python is used when it comes to the AI part of the coding, and also for OpenCV 3, which is nothing but for using computer vision. Yeah. Web programming, because a lot of the time you have to maybe you use an HTTP web page to control a robot, or you want to use a mobile app. So a little bit of background into web programming, especially platforms as Flux is very handy when it comes to robotics engineering. Embedded system is the electronics part of it, and especially microcontrollers and single board computers are very important and needed, because that's actually the hardware or the brain part of the robot. Correct. And also the interfacing part of the robot is also um, the hardware interfacing, and the protocols which you'll be using to interface those sensors. Those are also a part of embedded systems. Correct. So hope this gave you a good idea about what are the key subjects when it comes to robotics. Yeah. Career roles, I think two areas I want to talk about. One is industry. Oil and gas does a lot of recruitment for robotics engineer, especially for things like exploration. They are also used in factories. Yeah, and then obviously you have automotive, as I said, that modern shop floor uses this. There is a lot of R&D also happening in the automotive sector for robotics. Example, self-driven car, sorry, autonomous car. Okay. Softwares, especially product companies who actually products and embedded science companies who actually makes softwares for robotics. There also is a high demand for robotics engineer in the field of product-based companies. Research, and this is open in multiple dimensions, be it in the department of mechanical, electrical, and electronics engineering, computer science engineering, because as you saw, this is an interdisciplinary thing. So it's a very lucrative chance to make a career as an R&D engineer uh, when you are studying robotics. So I think this was helpful in giving you a 10-15 minutes overview on robotics. Comment up if you have more questions, and if you found this video helpful. Thank you so much for listening, and I'll catch up with you with the next video.